Hello guys, good morning. And this is a daily LEETCODE program here. And the problem is determine if two strings are close. Okay, like they are given with two strings, and if you can, the two strings are said to be close if if you can attain one from the other using the following operations. Okay, how to attain one string from the other string by applying the following like given operations here. Like basically is saying that you have to do some operations and get the actual string, like if there are two strings s and t, and you have to apply some operations, given operations in any of the string to make the two strings equal. Okay, so the operation one is you can swap any two existing elements. Okay, you can swap any existing elements. Okay, existing characters, like uh, in a string there are some characters, you can only perform this operation only with those characters. Like existing characters means this thing, like the characters in that string. Okay, and transform every occurrence of one existing character, like occurrence in the sense here frequency, and transform every occurrence of existing character into another existing character frequency. Okay, like, and do the same with other characters. For example, see, like the occurrence of a is 2, a is 3, and b is 2 here, and we can transform occurrence of one character a to the other character occurrence b. I will transform here all a's to b and b's to a. This is the thing here. That's it. Like we have to transform, like all a's turn into b's and all b's turn into a's. Okay, that's it. And you can use of operations on either string as many as necessary. As I said, you can do as many as operations. You can perform millions, trillions operations on them, and have to make sure that those strings are equal in nature. Okay, given two strings, word one and word two, return true if word one and word two are close, and false otherwise. Okay, so for example, here see ABC and BCA. Okay, we can uh, so what we can do here to make a string as this thing, and I can do one thing here, like I will swap, apply operation one on these two strings, these two characters, and it will become, okay, we will apply this on this thing. Okay, so what I can do is I will swap first two characters. Okay, I will swap, let us take this as s and this as t. Okay, operation op1, what I can do is I will swap a and b here. Okay, ba, now the resultant string will be abc of s and bca of string t, and I'll swap these two characters now, ac characters now. Okay, so operation 2, what I will do is b c a s and bca on t. Okay, now we can see that in two operations we can make them equal. So in this case I can return true, right? So in this way we can do the swap sim. Like, okay, for this example, like for second example, if you observe, so this is the impossible case, right, to attain word 2 from word 1, right? So because the length of the word 1 is lesser than the word 2, so in practical case we can't attain the word 2 from word 1, right? Like word 1 from word 2, right? Yes, and vice versa. In any number of operations, you can do multiple operations here, right? You can do millions of operations. You can't get the word two from word one, right? Yes, this is an impossible case. So one base condition we got is base conditions. What we got is base condition length should be equal. Okay, base conditions are length should be equal on base condition. Okay, and coming to this example here, see, if you observe here, we are applying operation 2 here. Okay, operation 2 will be applied here. Okay, see, if you carefully observe here, what is operation 2? Every occurrence of one existing character can be character into another existing character, right? So we can transform A's to B's like B's to A's, and in this way, right? So in this way we can transform C's to B, B's to C, A to C, A to B, right? C to A, and A to B, B to A. In any way we can transform, right? So to get this right. So if you observe carefully here, if you observe one thing here, you get another base case here. See, if you observe the occurrence of every character in word 1, A occurrence is 2, okay, and B occurrence is 3. And coming to this thing, C occurrence is 3 and B occurrence is 2 and A occurrence is 1. What did you observe here? See, if you observe here, the characters in word 1 and the characters in word 2 are equal. Okay, see, the characters in word 1 are should be in the should, like there should be similar characters in word 1 and word 2. Okay, so whatever the characters are there in word 1, there should be in word 2 also. This is the final condition here. So at that time only, right? If see, if suppose there is something D here, okay, with four something. So in word 1 there is no D there. So how can we make word 1 from word 2, right? How can we make them equal if there is no character that if there is no D in word 1, like we can't make, right? So this is the case. This is the another base here, another base condition, another condition we need to look at it. So what is this? Every char in word 1 should be in word 2. Okay, or vice versa. Okay, every character in word 1 should be matched with every character in word 2. Okay, whatever the characters are there in word 1, the character should be also in word 2. Okay, if there is an extra character in word 2, then it is not possible to make the two strings equal, right? In that case we will return false there. Yes, so this is the one condition we have to look at it. And another condition, if you look at it, if you like if you look at it, so the sequence of frequency, I repeat, the sequence of frequency here. The sequence of frequency. See, what is the sequence of frequency in word 1? 1, 2, 3, right? And in word 2, 3, 2, and 1, right? If we sort them up like 1, 2, 3, and this also will become to 1, 2, 3, right? So the sequence is same here. right? The frequency is same, the frequency sequence is same. Like if the frequency sequence is same, we can map with like any of them, right? uh, C can be mapped with B. Like if you want to change something here, like see uh, what we can do is, if we uh, if we want to make vote 1 as vote 2, then what we have to do here, we have to make C as 3 character. So we can do apply operation 2 here, right? So we can apply operation 2. Now what will be the operation? What will it become? Now it will become B, A, C, 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 and A, right? That's it, right? So is it now C is matching with C, right? So and another what we can do is, we have to make B count as 2, right? So our B count is 1 here, we have to make them 2 here. So what we can do, we have to we have to apply operation 2 on B and A. So what it will become? So what it will become? A, B, C, 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 and P. That's it, right? Is it okay? And last operation is applying operation 1 on this thing. We have to swap C and B here, right? C at index 2 and C at index, B at index last. Okay, if we match that, if we swap the things, it will become this way. Like, did you observe one thing here? The characters, whatever the characters in word 1, the characters also should be in word 2, right? And another observation is the frequency sequence. The frequency sequence should be same as word 1 and word 2. For both word 1 and word 2, the frequency sequence should be same. If at all these three conditions match, then we can return true. Like like they didn't say that in how many operations we have to perform this, right? They said that we can do many operations, like infinite many operations. For doing infinite many operations, what are the conditions we need? The conditions are the length should be equal, and every character in word, all every character in word 1 should also be in word 2, and the frequency sequence of word 1 should match with frequency sequence of word 2. That's it. These conditions, if these three conditions are equal, then we can apply many infinite operations to make them equal. Then we can say that those two in many infinite operations we can make them equal, right? So what are the three conditions again? Length should be equal, every character in word 1 should also be in word 2, okay, and frequency sequence of word 1 is equal to frequency sequence of word 2, right? And I have solved it in two methods. Like one is the hash map method, hash map, and another is taking frequency. I think this solution is based on implementation only. So uh, this is easy to implement. Like this requires many data structures like a hash map and list. Okay, like we require two data structures here, and uh, here the space will be more, and here there will be a constant space if you use frequency array, because 26 letters only, right? So there in alphabetical letters we are only using small case lowercase English letters, right? And only 26 letters, like 26 is a constant space only, we can consider it as constant space. And okay, we will be using here big of one constant space here if you use frequency array. And I will be explaining the solution with this frequency array only, and I will tell you to solve this using hash map also. It will improve your implementation skills while doing it with the hash map. Don't worry with the space complexity here. If you try to implement it with the hash map, then you will be good in syntax and good in implementation skills. Like this is the optimal approach here. Like hash map is also a good solution, but it will takes an big of an space here. But in frequency array, it will be we will not take any extra space here. Okay, so I'll be explaining the solution using frequency array. So let us jump to the solution here. Okay, so as I said, I need to count. I need to have the frequency count, right? So had the frequency count here. Okay, and I've um, I've stored the frequency here, uh, like ch minus a gives the frequency array, like how to store the frequency of a character here. Like in frequency one, I have stored the word one frequency here, and frequency two, I have stored the frequency of word two here, and this is the condition I need to handle with. Okay, so what is this condition is? So if frequency I is 0, like in frequency 1, the character is not present. Okay, if the character is not present in word 1, if it is present in word 2, then it is a false condition, right? As we already discussed here, right? So if there is a d in word 2 and there is no d in word 1, then it is not possible to make them equal, right? So in this case we can return false. So that is the case I've written here. Okay, so if frequency of I is 0, that means if word 1 does not have the character a, and it has in word 2 the character a is present in word 2, then it is a false condition, right? So as and vice versa, if a is present in word 1 and a is not present in word 2, then it is also a false condition, right? So this is the condition I've used here. Okay, and have sorted the frequency array to match the frequency sequence. Okay, I have sorted the frequency 1 and frequency 2, and I'm doing the check for frequency sequence here. Okay, if frequency I is not equal to frequency 2 I, then we can return false, right? So if yes, like for example, uh, yeah, what we did is we are sorted, right? We have sorted in ascending order. So what we got, 1 2 3 and 1 2 3. For example, here we got 0. Okay, so 1 is not matching with 0, right? So we cannot apply operation 2 on this, right? If the frequency is not equal, then we cannot apply the operation 2, right? So in this case we have to return false here. So if the frequency sequence is not matching, then we can return false here. Otherwise, if these all conditions does not match, does not turn out to be false, then we can return true. Then we can perform as many of operations we want, and we can make them true. Yes. And one more condition we need to add here is if word one dot length not equal to word two dot length, then return false. Okay, so we'll just submit it. See, as a, as it is passing, it is good to go. And coming to the time complexity of this solution, and as we discussed, the time complexity will be big of 1, that is big of n solution only, and spaces c will be big of 1. Okay, this is the solution here. If you want the hash map solution, then comment down below. I'll be providing you with the hash map solution also. Okay, thank you.